All right. For those of you who are moving on to calculus or pre-calculus, classes like that in the not too distant future, this is a really useful skill to be able to understand piecewise functions. So in graphing this, I want to be really clear about how my domain gets divided up, right? Let's actually use two colors to identify this. So our domain has this very clear split, right, at this value x is equal to 3. So to the left of 3, and actually including 3 as well, we're going to use one function. To the right of 3, we're going to use the other function. And that's how we get to, that's how we graph this all together. Okay, so just be really careful. You want to make sure that up top, this 6 minus x does not accidentally cross into values where x is greater than 3, and equivalently, you want to make sure this 3 as a function, right, does not accidentally cross up here. We want to keep that boundary line very, very clear. So what I'm actually going to do is I'm going to bring in a Cartesian plane. I'm going to bring in a Cartesian plane. I like to use this to graph just because my lines are not always straight when I'm doing it digitally like this. I would encourage you, to draw a very beautiful graph as you go through this. I want to point out all of your graphs. This is the, taking pride in the quality of your work. All of your graphs need to be labeled with arrows on all of the axes and the x and y values labeled. And I'll say some of the numerical markers. I don't need all of them listed, but maybe the ones that you use. It needs to be really clear how things are measured out, okay? So what I actually want to start with, I kind of started drawing this out. I want to make this boundary line at 3 right here. And I actually want to, I'm going to kind of temporarily draw in a boundary. So let's actually go with orange as our boundary line here. So I'm going to draw this in as a dashed line. You do not absolutely have to draw this line in, but it might help for my visual people to see that to the right of this is our function where x is greater than 3. So this is where we're graphing f of x is equal to 3. That's this right here, right? Where x is greater than 3. And then to the left of this, over here, right, we're graphing f of x is equal to 6 minus x, where x is less than or equal to 3. So that orange line is the cutoff. Okay, anything from the green, whatever we're graphing, stops at this orange line, and whatever we're graphing in blue, it starts. It does not go to the left of this orange line. That's your boundary. Okay, let's work on the green one. That's the first one we've got. So you've got f of x is equal to 6 minus x. And you've got f of x is equal to 6 minus x. And you know what? Let's actually just draw this out in a XY table, right? And so my lines are not always straight. But let's do this in an XY table so that you can just start finding function values, right? I do recommend that you always start with this boundary number, and that's whether or not it's included. So I'm also going to use it when we do the blue portion of this in a moment. We'll get there when we get there. But what is the value of f of 3? Well, that's 6 minus 3, which is 3, right? And some of you will write this with the ordered pair, x, f of x. That's fine. Do it make sense to you? So as we graph this, we have our 3 already on the x-axis. I'm going to go up 1, 2, 3 right here, and I'm going to put a closed dot here because this has an or equal to. So this is an included point. Now, that one point on its own does not tell me a lot about this graph. So I need some other way of making sense of this. I will point out that this is a straight line, right? I know that because x has just the first degree. There's no extra powers attached to it, like x squared, x to the third. Also, I could put it in mx plus b form. And there's some of you that might prefer that. So you can think of this as y is equal to 6 minus x or maybe even negative x plus 6, right? So you adjust for what makes sense to you. I can actually work with this format right here, right? And I can actually graph, that's a y-intercept at 6. So there's some flexibility with how you develop this. Play around with a couple of different formats so you can kind of see what works for you and what doesn't. So because this is a straight line, I only need 2 points so I can connect the dots. I have those 2 points right here. If you're uncertain of whether or not those points are enough, plot some more, right? Plug in any number you want that's smaller than 3. A 2, 0 is a great number to plug in. A negative 10, right? Whatever you're feeling to plug in here, and anything smaller than or equal to 3 is fair game. So if you graph this, again, it's a straight line, as straight as I can draw it, and it should go out towards infinity, so it should get an arrow on that side, okay? On the other side, on the right side of this, we want to do the same thing for f of x is equal to 3. And I kind of alluded to this before, f of x is 3. Even though this 3 value is not technically included in the domain, I'm still going to plug it in. Maybe you leave a note to yourself that this is open or something so you don't forget, but I'm still going to plug it in. And this is an unusual function because it's constant, right? So whatever I plug in, it doesn't matter. I always get 3 as an answer because of the 3 right here. So 1, 2, 3. So this is an open circle for our blue function, but a closed circle for our green function. The green one actually overrides it. It's stronger by definition because it's a closed circle. So they kind of sit on top of each other. If those numbers didn't line up, which we'll see an example where that happens, I would just draw that as an open circle right in line with it, okay? We'll get to that in the next. So again, anything that's larger than 3 is fair game. You can plug in 4, you can plug in 6, you can plug in 24, whatever sounds good to you. The great thing about this function is all of those are equal to 3. It's not the most interesting function out there. So let me maybe plug in 4, and we'll throw 6 in there as well. But we have just these straight, these flat kind of points, if you will. So you actually could even go back here and also say, hey, I know this is a line, right? It just happens to be a horizontal line, and it goes this way. So your final graph, if I can maybe go in here and erase some of the excess. Let's get rid of all of this stuff and get rid of the function too. We don't always include this as we write it out. Get rid of that, and like this, okay? This would actually be a fair kind of final answer. If you have some of that extra stuff like I was drawing, that's fine. But it almost looks like the hands of a clock to me, right? Where it kind of goes down and then kind of goes out like this. You do have that graphing tool on the bottom of your Canvas page. You're more than welcome to try it out. Okay, so I will see you in just a moment for the second example.